Hello and welcome to this Any Excuse for a Chemistry Experiment video. We're going to be looking at the required practical today. It's going to be looking at changes to concentration and how it affects the rate of chemical reaction. Got two reactions today. The first one is looking at turbidity. We're going to be looking at one of the products turning a solution cloudy. The second experiment is looking at gas volumes, and one of the products of this reaction produces a gas which we're going to collect in this gas cylinder. So here's our first experiment. We're going to be doing a reaction between hydrochloric acid and sodium thiosulfate. One of the products of this reaction is sulfur. So we're going to start off with two colourless solutions, and we should have sulfur being produced, turning our solution more turbid. So we need to do a couple of experiments here because we are looking at how the changes in concentration affects our rate of reaction. So we're going to start off with some hydrochloric acid. Here we go. This is a 2 molar concentration of hydrochloric acid. We're going to measure 20 centimetres cubed of it. And we're going to take our sodium thiosulfate. We're going to use 20 centimetres cubed of this one as well. There we go. Now, what we're going to do is we'll put our sodium thiosulfate straight into our conical flask. When we start our reaction by adding the hydrochloric acid, the reaction will start to take place. Particles will collide and they will produce our sulfur. Now the sulfur is going to turn our colourless solutions cloudier and cloudier. Underneath my conical flask, I've got a cross here, and what we're going to do is we're going to look for the amount of time it takes for us to no longer be able to see the cross through the solution. So I'm going to pour in the hydrochloric acid at the same time starting the stop clock. Here we go. Give it a swirl, make sure it's well mixed. As you can see, it's starting to colour now. It's becoming more challenging to see the cross. I'm looking through and there, I can no longer see the cross. So we need to record our results because we want to see a trend when we change the concentration. So the concentration of our acid was 2 moles per decimetre cubed. And the time was 55 seconds. Next we'll do is we'll dilute our hydrochloric acid and we'll start again. So we've set up our next experiment. I've diluted the hydrochloric acid, so I now have 1 mole per decimetre cubed of my acid. I've measured out my 20 centimetre cubed of sodium thiosulfate. Remember, we need to keep our variables the same, our control variables the same. And as we did before, pouring in our acid, starting the stop clock at the same time. There we go. Give it a swirl to make sure it's well mixed. So we now need to record our results. So the concentration was 1.0 moles per decimetre cubed, and my time was 1 minute and 8 seconds. So I need to convert that to seconds, so that is 68 seconds. So there we go. We've done our experiment. What we've done is we've changed our concentration. We started off at 2.0. We then went to 1.0 moles per decimetre cubed, then 0.5 moles per decimetre cubed, and the last one was 0.25 moles per decimetre cubed. And as we can see, the time taken increased as we went. But how does that then relate to rate? We've got to remember our rate is equal to 1 over t, or the amount of product formed divided by the time taken in seconds. So we can work out the rate of reaction at each point. So here we are, the experiment number 2, looking at how concentration changes the rate of a reaction when we're measuring gas volume. So here we are, here's a gas syringe. What it's going to do is any gas that is produced in this conical flask, when the bung is on, the gas will travel up the pipe through our delivery tube into the gas syringe, and the gas will push the cylinder from the gas syringe out. All right, so here we go. In my conical flask, I've got 40 centimetres cubed of 1 mole per decimetre cubed hydrochloric acid. We've got some magnesium ribbon in here, and what we're going to do is we'll place the magnesium ribbon into the conical flask, put the bung in, and we'll watch the gas be delivered. Now, what we're going to do is we're going to measure the volume of gas every 15 seconds, and then we're going to record it in my results table. Here we go. So in, start, bung on. "15 seconds, we are at 6. 30 seconds, we are at 14. You can see we're bubbling furiously there. Waiting for 45 seconds. Now that is at 20 centimetres cubed. Next we're looking for 60 seconds. We're still bubbling away nice and furiously. And now that is 26. $59. So my chemical reaction has stopped. No more bubbling going on. No more gas being produced. My reaction has completed. So let's have a look at the science now behind our rates of reaction practical. To start off with, we need to focus on the collision theory. Now, collision theory requires us to know that particles need to collide with enough energy for a reaction to occur. What we're doing in this experiment is we're changing the concentration, which equals the number of particles. More particles is going to equal more collisions, more successful collisions. Less particles, lower concentration, is going to equal fewer successful collisions. Let's have a look at our first experiment, looking at the changes in turbidity due to changes in concentration. So we started off with hydrochloric acid and sodium thiosulfate. The products of this are sodium chloride solution, some water, some sulfur dioxide, and some sulfur itself. The sulfur is the bit that we're looking for. The sulfur is the solid. Let's be confident with our state symbols. If we have a look at our results table, we can see that the time it took for the reaction to occur as our concentration decreased, the time for the reaction to take increased. If we look at this as a graph, we can see, using the concentration on our x-axis and our time on our y-axis, that as the concentration increases, the time for our reaction decreased. But the required practical wants us to know about rate, so we need to do a separate equation. We need to do 1 over t. And our 1 is the amount of time that it took for our cross to disappear in our experiment. If we do this calculation, we can see that the concentration increases and the rate of reaction also increases. But it's not a straight line, and we'll have a look at that later. In our second reaction, we had magnesium ribbon and we had hydrochloric acid. The products of this are magnesium chloride in aqueous solution and hydrogen gas. We were measuring the gas as it was being evolved. If we have a look at the results that we collected from our experiment, we can see that as the time increased, the volume of gas also increased until there was a time when the volume of gas ceased to increase. If we plot this on a graph, we can see that we have a rate of reaction that is fast at the beginning. It then starts to slow down towards the end, where it levels off when no more gas is being evolved. The reaction had stopped. Using this graph, what we can do is we can now work out the rate of reaction by looking at the curve. Let's pick a plot on our line of best fit. If we draw a tangent on this line of best fit, what we can find is that we have a calculation that we can use in order to work out the rate, because the rate of our reaction is equal to the tangent. So our rate is equal to a change in y-axis divided by a change in the x-axis. Let's have a look at some of the exam skills that we're going to need. We need to know the method. Let's look at our first experiment. We want to stand the conical flask on a piece of paper with the cross on it. We want to pour 20 centimetre cubed of sodium thiosulfate into our conical flask. At the same time now, we need to pour 20 centimetre cubed of our 2.0 moles per decimetre cubed hydrochloric acid into the conical flask. We want to start our stop clock and we want to give our conical flask a quick swirl. We will stop the stop clock when we can no longer see the cross through our solution. Then what we need to do is we need to repeat the whole experiment using different concentrations of acid. The method for our second experiment looks at using 40 centimetre cubed of our 1 moles per decimetre cubed hydrochloric acid. We pour that into our conical flask. At the same time now, we want to add our magnesium ribbon. We want to put the bung in our conical flask attached to our gas syringe, and we want to start our stop clock. Now we will measure the gas volume every 15 seconds. Exam tips. I've seen many questions, lots of them are centred around writing a method or describing the results. We need to know the equipment. Be confident with the names of each of the pieces of equipment that we've used. We might get a results table. Be confident, look out for those anomalous results. If it doesn't match the pattern, circle it, cross it through and ignore it when you're working out your mean averages. Be confident with your collision theory. You will have learnt that with your rates of reaction topic. Be confident with working out how to calculate rate, 1 divided by time taken. Also be confident with the units of rate. And finally, be confident with being able to manipulate those graphs, drawing tangents and working out the rate by working out the gradient of that tangent. Thank you very much for watching this Any Excuse for a Chemistry video. I've been enjoying making them. Look out for all of the required practicals in this playlist. If you liked it, click the thumbs up button, post a comment. Otherwise, I'll see you next time. Thank you and goodbye.